Hey y'all, so in this video for the final exam review, I'm now going over the rest of the questions. So starting at number 21. So with this equation here, now keep in mind the question is asking about the solution. So thinking about test taking strategy, one thing that I would do is, right, if you recall about extraneous, we always focused on the bottom. So if you recall, notice how here in the bottom, right, that's your extraneous. So that means here, and then if you were to factor, remember, this is the same as x minus 5 times x minus 3, the two factors here given to us. They multiply to get 15 and add to get negative 8. So really, the extraneous solutions are x cannot equal 5 or 3. So then they say that this person here solved and said that the solutions were 1 and 3. Well, we know for a fact now that 3 is one of the extraneous. So 3 is not a real solution, 3 is extraneous. 1 and 3 are both real. So here we know that 3 is extraneous. Now, is 1 also extraneous? No, 5 is. So here, just by looking at and focusing on the denominator, because that's another way, guys, of looking at the extraneous solutions, then here, that's why the answer is B. So then 22. Here's what we're used to. So what makes this extraneous or undefined? Same thing. What do we focus on? The bottom. So this is the same as asking for the extraneous, even in the equation format. Focusing on our bottom, our denominator, same thing, focus on the bottom or denominator. No need to worry about our values up top. So here I've got factoring, so what multiplies to get negative 18? Remember, right, if you're multiplying to get a negative, then we need to have different signs, positive and a negative. And then add to get 3, or in this case, subtract, right, because of the different signs, and use answer choices 2 as a guide. So in this case, this would be positive 6 and negative 3. They would add to get you 3. So that means what's your extraneous? Well, one of them here, which is negative 6, because remember, right, change the sign. And as also here, x cannot equal 3. So now 23, we're looking for 3 statements. So now remember the first, looking at domain. Domain is the x values. So whenever we did our solving and simplifying, remember we always got the domain as all reals except for, we got the values from our vertical asymptote, what our x was equal to, as well as the whole, what our x was equal to. So here it says that the domain is all reals except for x is equal to 2. Well, I see here a vertical asymptote, which is at x is equal to 2. But we also have a whole here at 3, 2. So notice how where x is 3. So because of the whole, that's why the answer is not A, because it's more than just at 2, it's also here at 3, because of the whole, which means OB is an answer because the whole is at 3, 2. Now keep in mind, the vertical asymptote was x equals, so the horizontal was not x, but y equals 1. So this is y is equal to 1. So that's why C is not our answer. Then here, as x approaches infinity, so as we're going to the right, is our graph going down, down, down to negative infinity? No. Notice how it's approaching but never reaching here, that asymptote at 1. It's never going past it. So not negative infinity, but, 1, not negative 1. Sorry about that. It's approaching 1, our asymptote here. So that's why it's not D. So let's check to make sure then the other two answers are E and F. Our 0 is, boom, right here crossing the x-axis at 1, 0. Then even though 10, 15 is over here, not on the graph, our graph is reading left to right, constantly decreasing. So that's why here, E and F are solutions. So now 24. Here, if you want to help you, option 1. We could graph this in Desmos to see which has the vertical asymptotes at -2, 3, and the y-intercept at 0, -1. Or remember, right, here the bottom always gave us our asymptotes. So if you recall, if it was here, but then how would we say if this was x minus 2? Well, remember, right, we always change the sign. So this here says x is equal to 2 and -3, but we need to switch the signs, you see? So that's why I'm not going to even focus on A or C, because this is also 2 and -3. Now notice, right, here we go. According to our denominators here, we're at -2 and +3, right? Because you have to change the signs. So now if you would like, graph and see which of these has the y-intercept at -1, which one? So we could graph this in Desmos here. So here, just to show you. So to show you here, oh, sorry about that. Hold on. Oh, I got to fix this. All right, here we go. So I went ahead and graphed the first one. So I think it was option B. So notice how here our graph is crossing right here at 0, -1. So just by graphing, I can see that's why the answer here is B. Oops, sorry about that. Nope. I don't know what's happening. Sorry. The answer is B. There we go. All right. Then same thing for 25. If I'm given a graph here or equation and I'm looking to see which graph it's representing, then graph this in Desmos. You just got to make sure to put this here in parentheses, right? So I already went ahead and let's see if I got this. I graphed that already. So see how here I'll exit out. Notice how here you got to keep it up top in parentheses divided by 4x squared minus 4x. And then notice here's your graph. Zoom in, zoom out, so that now you can see, according to our graph here, that's why the answer is B. So now going to the unit circle. So with the unit circle sign, that is your y-coordinate. So if I want to know what's the y-coordinate at pi over 6, here's pi over 6. The y-coordinate is 1/2. Now tangent, remember, is y divided by x. So at 2 pi over 3, the y at 2 pi over 3, which is here, radical 3 over 2. So radical 3 over 2 divided by -1/2. That was the x-coordinate. So now remember, right, when dividing, keep, change, flip. So radical 3 over 2 times -2 over 1. So notice how 2's cancel out. 2 divided by 2 is 1. Now here you're multiplying a negative and a positive, so that's why we still have a negative value. Then radical 3 is up top over 1. So that's why here it's just negative radical 3. Then cosine. Remember, cosine is the x-coordinate. So we just need the x-coordinate, right, at 11 pi over 6. So here's 11 pi over 6. Cosine is radical 3 over 2. So then tangent, again, y over x. So here we go, at 5 pi over 3. So 5 pi over 3, which is here, the y-coordinate is negative radical 3, oops, sorry, wrong direction, negative radical 3 over 2 divided by x, which was 1/2. Again, keep, change, flip. So negative radical 3 over 2 times 2 over 1. 2 divided by 2. So notice how again here you've got negative radical 3. Negative times a positive, and radical 3 was up top. So just to show you guys, because we didn't have it, what if we had 1/2 divided by, let's say, negative radical 3 over 2, right? So again, 1/2 times 2 over negative radical 3, right? 2's Again, we have a negative because a negative times a positive is a negative. But see how the radical 3 is in the bottom. This is 1 over radical 3. So that's when you had to rationalize it, and we end up with negative radical 3 over 3. That's when you get the fraction here, when it was in the denominator and we had to rationalize. So now solving our equations. Again, it's like solving for x, right? Don't worry about the trig function. This is the same as saying this is 2 times x minus the radical 2 is equal to 0. We would always add or subtract first, then multiply or divide, right? So here we go. We're going to add the radical 2 first here. So 2 times sine of x is equal to radical 2. Then here we're multiplying sine by 2, so divide by 2. So notice we're looking for where is sine? Radical 2 over 2. So where is our y coordinate? Radical 2 over 2. So we're looking at the y coordinate. So notice here it's negative, so it's not here. But radical 2 over 2, so at pi over 4, and here at 3 pi over 4. So these are the two solutions, pi over 4 and 3 pi over 4. So then cosine of x, well, it's already been solved for us. So we're just looking for where is cosine radical 3 over 2. So again, where is the x coordinate, right? Radical 3 over 2. So we're looking at where the x coordinate is radical 3 over 2, boom, at pi over 6, and right here at 11 pi over 6. So pi over 6 and 11 pi over 6. Now again, here we're going to have to solve for tangent. We're adding 4, so subtract 4 from both sides. 4 times tangent of x is equal to negative 4, right? Because that's 0 minus 4, negative 4. Now we're still multiplying tangent by 4, so now divide by 4. So tangent of x is equal to negative 1. But because it's a negative, right? And remember now, tangent is y divided by x. So we're dividing. That means to get a negative, one has to be positive, one has to be negative. They have to be different signs. We're not looking for two negatives because two negatives when divided make a positive. So that's why we need different signs here. One positive, one negative. And we are also dividing to get 1, which means they have to be the same value. Like 2 divided by 2 is 1. 3 divided by 3 is 1. So we're looking for different signs and the same. So like for example, these coordinates are the same, right? So if you were to divide them, you would get 1, but they're the same sign. So that's a positive 1. So what would give us negative 1? Here at 3 pi over 4, they're the same value, but one positive, one negative. So when you divide, you will get a negative 1. So then the other value is 7 pi over 4. Notice how different signs. So at 3 pi over 4 and 7 pi over 4. So then 30, we are still solving this equation that represents a tide height. We're just looking for what is t if the height is 8. So 8 feet here. 8 is equal to 6 times cosine of t plus 5. Now we can go through and solve. Subtract 5 from both sides. Here I've got 3 is equal to 6 times cosine of t. Now what do? Divide, right? Opposite operation by 6. So notice how we're looking for where is cosine of t equal to 3 over 6, which is 1/2. So where is the x coordinate? 1/2. So again, x coordinate is 1/2 at pi over 3 and 5 pi over 3. There's our x. So pi over 3 and 5 pi over 3. So notice how we've got our decimal answers, right? So you just got to divide and put this in the calculator. Pi divided by 3 and 5 times pi divided by 3. That's how you should get B when you do pi divided by 3, and C, 5 times pi divided by 3. Now here, we're solving the system using our matrices. Remember, you have your two matrices, right? You have your A matrix, which is your coefficients. Now watch your signs. So like the top row here should be 4, -3, and then 1. So keep in mind, keep the sign in front. And then your B matrix will be your total. So like 32, -19, and 34 here. So again, just to show you, you should have, here's our matrix, and then here is the other matrix. So now, how do we solve? Do we just do A times B, A plus B? What do? We do inverse of A. So A to the -1 times B. And that's how you get the three answers. X is 3, Y is -7, and Z is -1. So that's how here you got to make sure to set up and solve. So X was 3, Y was -7, and Z is -1 from your matrices. And so now here with question 32, we have two variables. We've got different bracelets that cost $3 and $6. So two different bracelets, so X and Y. So here I've got 3X plus 6Y. Well, keep the money together, right, with the money. She sold 120 bracelets for a total of $540. So keep the money together. So if there were these costs sold for 540, 3x plus 6y is equal to 540. So then how do we set up here if we sold, or if she sold 120 bracelets? X plus y is equal to 120. So now again, set up the two matrices. So like what is going to go in the coefficient matrix? Well, you have 3, 6, and then what goes in the bottom? 1, 1. Then the other would be your total, the 540 and 120. So again, so it looks like this here. So here we go. Again, what do we do to solve? Inverse of A, right? A to the -1 times B. So notice how they were actually sold 60 of each one. So there are 60 and 60. So now 33. Here it takes 4 hours to make a small wagon. So X is our small, and 6 hours to make our large. So Y is the large. So this is like the 4X plus 6Y, right? That's how long it takes. No more than 60. No more than, which means it's got to be less than or equal to 60. So notice how it's already been graphed for you. So less than, which means that is everything below. Then here, they want to make or have at least 6 small. And small was the X. So at least 6. So X is then greater than 6. So that's why here at the 6, see how it's already been graphed for you? Go greater than. So notice, where did the shading overlap? Right here in that triangle. So right here. So all we're focusing on is this triangle section. So you're looking to see which of these possible combinations. Well, I can already tell 0, 2, and 1, 2 are way too small, right? Because they're over here. You just got to be careful because this is your X, which is your small, and this is your Y, which is your large. So here, small, so 8 small, but 6 large is out of the boundary. So here, so 8 small, 4. Sorry about that. So, oh, yep, sorry, I flipped that. All right, that's 8 small, 4 large. So 8 small, 4 large. So notice how the 8 small, 4 large, 8 small is here, 4 large is here. So that's why here the answer is C, because that says 6 small, that's your X. So 6 and then 8. Notice how here we're outside of the boundary. So that's why here the answer is C. So now 34. Whenever you're asked for the minimum or maximum value, you're focusing on the furthest out points of the solution region, which is the vertices, the corners. So here we're at 2, 4, at negative 5, 2, and 3, negative 4. Then use the equation. So in this case, the cost, which is the 12x plus 20y. You're going to use the coordinates. That is your x and your y to solve. So like here, 12 times x plus 20 times y. So let's say we're going to focus on the point 3, negative 4. X is 3, so 12 times 3 plus 20 times y, which is negative 4. So here, when you put this in the calculator, you get negative 44. So now Q4. Now, see how they're both positive? I want the minimum value. So I'm not going to even worry about that because that's going to be the greatest. That's positive. So then let's focus on negative 5, 2, our last point here. So 12 times, what is the x? Negative 5. Plus 20 times, what is the y? 2. So here you get negative 20. So which of these is the smallest, the minimum value? Negative 44.